Okay, hi everyone. So if you're a competitive programmer or you love to explore the world of data structures and algorithms, then chances are that you've already stumbled upon the concept of segment trees, right? So lately I've been getting a lot of requests from people to talk about how I use segment trees and how do I efficiently implement segment trees during a contest. So do I code them from scratch every time, or is there some neat way to do it? Right? So if you're someone who struggles with the implementation of segment trees, for various use cases, then fear no more, because in this video, I'm going to be discussing about how to use a template for a generic and all-purpose segment tree that I've written myself. So using this template, you'll be able to code up any kind of segment tree within a matter of a few minutes, and consequently, you'll be able to solve a lot of hard problems during a contest, and that too at a much faster pace, right? So yeah, let's get started. All right, so this is the template. So traditionally in a segment tree, there are three functions that we need. One is the build function, one is the query function, and the other is the update function. So I have all these three functions defined here. The update function obviously is a range update function. So this segment tree does support lazy propagation. And yeah, so if you want only point updates, then you can pass in L is equal to R here, right? And that will do your job. So let's start from the top and see how exactly you can use this template to code up any kind of segment tree and solve any problem. So let's start from the top here. So let's first understand what these T and U are. As you can see here, T is the node and U is the update. So if you're not familiar with this syntax of templates, then that's quite all right. It will still make a lot of sense to you. Don't worry about that. So this T basically denotes what exactly are you storing in your segment tree. And this U exactly stores like what is the nature of the update. Now in 99% of the problems, these T and U both are going to be integers. So you don't really need to worry about that. But only in special cases will these be something else. Sometimes they might be pairs, sometimes they might be a custom structure, things like that. But I'm going to be taking an example of when these things are not integers as well, so you don't need to worry about that. But for now, just understand that this T stands for the nature of the node. That is what exactly are you storing in the nodes of your segment tree. And this U is the nature of the updates. That is how exactly are you going to update the range of a segment tree. Okay, cool. So the next thing is this notion of the identity element and the identity update. So as you can see, the identity element is nothing but an element such that the result of this combine xi is equal to I for all x. Okay. So I'll talk about this combine function later, and if it's not yet clear to you, then it will become crystal clear. So you don't need to worry about that. And the same thing goes for an identity update. So it is again an element I such that the output of apply x comma I is exactly going to be x. So essentially, an identity element and an identity update are nothing but two elements such that they don't change the output of this combine function and the apply function respectively. So it's easy to understand. We'll talk about it later. So for now, let's see what are the locations where you actually need to make some changes. So the great part about this template is that you need to make changes in exactly three locations. So first is this combine function. Second is this apply function, and the third is this combine update function. Okay, so let's see what changes you need to make in the combine function. So again, it's quite self-explanatory. This combine function, what it does is it just combines the result of two nodes in the segment tree. So for example, if you want to query for the sum of a range in a segment tree and you need to combine two ranges, then you essentially need to take the sum of these two ranges, right? So that's what I'm doing here. You can just say T answer equals to L plus R, where L denotes the left child and R denotes the right child. So at the same time, let's say you wanted the max of a range, then you can just say T answer is equal to max of L comma R. Again, instead of max, if you wanted the min, you can do the exact same thing. You can say T answer is equal to min L comma R. Also, let's say you wanted the GCD of a range, then you can just say T answer is equal to GCD of L comma R. And that's it. That's all the changes that you need to make in this combine function. I think you get the idea what you need to do here, right? So this is done. The second thing where you need to change is the apply function. So this apply function is nothing but a function which applies an update to a node. Okay, so you have this node cur and you have this update UPD, and this node cur denotes the range from TL to TR in your array. So the node in the segment tree denotes the range from TL to TR, and you need to apply this update UPD to it. So right now, this update basically is assigning a value to the range. Okay. Now, yeah. So this segment tree is essentially built for querying for sum, and the updates are assign a value to a range. So if you want to assign this value UPD to a range from TL to TR, then how will you apply this update to a node? So a node is storing the sum of the range, right? So you just apply this update to the node. And what that means is that all the elements in the range from TL to TR will be replaced by UPD, which means that their sum will become TR minus TL plus 1 into UPD. So you will just say T answer is equal to TR minus TL plus 1 into UPD, and then you can return the answer. So if this was not the case, let's say in the update you had to increment a range by a value. So let's say you had to increment range by UPD. So in that case, you would have just done the answer is equal to cur, which is the initial value. And then you can just add this thing, tr minus tl plus 1 multiplied by UPD. Okay, so I hope this makes a lot of sense. Otherwise, let's say the update was, let's say that the query was to take the maximum. So query is to take max and update is to assign a value, something like this. So in this case, how will you apply an update? So you know that in the query of the segment tree, you are taking the maximum, and in your update, you are changing every element from TL to TR to UPD. So the maximum will become UPD, right? So you can just say T answer is equal to UPD. Okay, and same thing for minimum. So I hope you get the idea. Good. So yeah, all you need to do is to just apply this update to a node of the segment tree. Remember that what you are querying is what needs to be stored in the answer. So here we were querying for the sum. So we'll store the new sum of the range from TL to TR, which is TR minus TL plus 1 into UPD. So yeah, I hope this makes sense. And now the third and the last location where we need to change, this is the combine update function. Okay, so now let's see what we need to do here. So essentially what happens in a lazy segment tree is that when we enter a node, we apply the update that was stored in that node, and then we push that update down to its children, right? So we'll just push this update to the left child and to the right child. And the left child and right child might have an update of their own. And that is the reason why we need to combine the two updates of a child. So essentially we need a function which combines two update of a node. Even if you don't know why we need it, just you can just use it as a black box, but just remember what this function does. All you need to know is to just understand what this function is doing. You don't even need to understand how a segment tree works. So essentially a combine update function just combines two updates. So essentially there is this old update and there is this new update, and you need to return the combined update out of these two updates. So again, in this use case, the update denotes assigning a value to a range. So if previously we were assigning this old update value to a range, and now we are assigning this new update value to a range, then obviously this old update is useless to us right now. And so we'll just say that answer is equal to new update. So this is the case when we are assigning a value to a range. So let's say that we were adding a value to a range. So let's say we were adding a value to a range. So in this case, how will we combine two updates? So initially we were adding old update to this range, and now we are adding new update to this range. So that means in total we are adding old update plus new update to the range, right? So we would have just said answer is equal to old update plus new update, something like this. Okay, so this is the case when we had to add something to the range. But in our case, we were just assigning a value. So the old update becomes useless when we get the new update. So we can just say answer is equal to new update. Cool. So I hope this makes sense to you guys. So yeah, these are the only three locations where we had to make changes. Now let's just get back to the concept of an identity element and an identity update. So as you can see, an identity element is a element which returns combine of x comma I is equal to x, which means that it doesn't change anything if we combine an element with the identity element. So for example, if this combine function is just summing up the two values, then the identity element becomes 0. At the same time, if we are taking the maximum, then the identity element becomes minus infinity, because the maximum of anything with minus infinity will be that same thing, right? And again, if we are querying about minimum, then this identity element just becomes infinity. Okay, so I hope this is clear now. Let's just talk about this identity update as well. So it's just the same thing when we come to this function apply. So if we are applying an update with the identity update, we just want the node's value to be unchanged. So in this case, let's say that we were assigning a value, then the element that we choose as the identity update is totally up to us. So we can just choose it to be -1 because no updates will be of -1 kind. So we can just say that if the value of an update is -1, then that means we don't need to assign anything. Okay, so let's say that the updates were to add an element to the entire range. So in that case, we would have chosen the identity element to be 0, because if we add 0 to a range, then it doesn't change anything. Okay, so yeah, I hope this notion of identity element and identity update is clear now. Cool. So yeah, this is all that you need to do. You just need to change this combine function, you need to change this apply function, and you need to change this combine update function. And that's it. That's it. You can just use this segment tree now. And with this, we finish with the explanation. Now let's come to the application and see how exactly we can use this segment tree during a contest. So I'll solve two problems from the CSES problem set. One is this range update and sums problems, and the other is this dynamic range sum queries problem. So this is the problem that we'll be discussing first because it's particularly an easier problem. So here, as you can see, we have been given with an array of n integers, and our task is to process q queries. So the queries are of two types. One is that we need to update the value at position k to u. So this is the same as assigning a range, assigning a value to a range, but the range is just of size 1. Okay, so this is a point update, but our segment tree will still work here. And the second type of query is that we need the sum of values in the range a to b. So you can see that this is exactly the same thing that I have done here. So we don't really need to change anything in these three functions. And we can just copy paste this segment tree and just use it without changing anything. So let's just see how we can use this now. So what we'll do is first we'll take in the array as an input. Okay, so then we'll initialize our segment tree. So just how we initialize a vector, we say vector of LL a, something like this, right? So that's exactly how you can initialize this segment tree. So you need to pass in the node and the update, both of these things here inside these angular brackets. So as I've already said, 99% of the times, both of these things are going to be integers. Okay, so that's what I do here. But also you also need to pass in 3 arguments. So you can see in this constructor function, I have 3 values here, n, identity element, and identity update. So that's why you need to pass in 3 values here. So I need a segment tree of size n plus 1 because I'm interested in ranges from 1 to n. And the identity element is 0 because we are taking the sums. And the identity update, as I already explained, is -1. Okay, and yeah, so this segment tree initially has initialized all the values to be identity element. But since we want to build this segment tree on this vector A, we can just call the build function on this vector A. So this is how you use the build function. Just make sure that the size of the segment tree and the size of the vector are the same. Otherwise, it will be throwing a runtime error due to this assert. Cool. So now we have built our segment tree and it stores the range sums for all the elements in the ranges. And these ranges are according to this array A. Cool. So now we read in all the queries. If the type of the query is 1, we just update the position k comma k by u. And if the type of the query is 2, then we just read in L and R and we query from L to R. So that's it. So this code works. If you submit it, it is going to work. So it is that easy. You just have to copy paste your template and you'll see that everything works. Okay, so yeah, this is the first problem that I wanted to discuss. Now let's go to a particularly harder problem. I would say this is one of the hardest problems in the range query section of CSES, but using this segment tree template, we can solve it in less than 3 to 4 minutes. So let's see how we can do that. Okay, so in this problem, we have to maintain an array of n values and we have to efficiently process 3 types of queries. So the first query is that you increase each value in a range by x. Okay, so you have to increment a range by x. So the second type of query is that now you need to set the value in a range to x. So you need to assign a value to a range. And the third type of query is that you need to find the sum of values in the range from A to B. Okay, cool. So now you need to process these 3 kinds of queries in which 2 are update queries and one is the like range query, right? So one is the query and 2 are the updates. Okay, so that's what you need to process. Cool. So now here we'll notice how we can use the same template, but in a modified way. So I just copy pasted the same template here, but this time there will be a bit of a difference. So obviously in the nodes of the segment tree, notice that we need to return the sum of values. So in the nodes, we'll still be storing integers, but you can see that the updates are of two kinds. So we can't just have an integer as an update, right? So we'll say that an update is a structure called update, and we'll just define this structure. And instead of integer, we'll pass in this structure as the value of u. Okay, cool. So what does this update structure actually mean? So as you can see, there are two types of things in this update structure. One is the set val and one is the increment. So essentially, what an update does is this means that the update is you first set the value to set val and then increment it and then increase it by increment. Okay. And you'll realize that if you have this particular definition of an update, then it is easy to write all of these three functions, the combine function, the apply function, and the combine update function. Okay. Cool. So yeah, also one thing I forgot to mention here is that when you are using segment trees and your update is not an integer, then you need to make sure that the equal to operator is defined for this update. Otherwise, this line is going to give you an error. So that is what I have done here. So for integers, the equal to operator is already defined. But for this structure, I have explicitly defined this operator. So if both the set val and increment operators are equal, then then the two structures are equal. So that is what this particular line of code does. It is just defining an equal to operator. Okay, cool. So yeah, let's see how we can do this. So the combine function remains exactly the same since we are summing up the values. Now let's go to the more interesting parts, which is the apply function and the combine update function. Okay, so these are the two functions. So what does the apply function does? It is pretty similar to what I already discussed. So it's just the same concept. You first assign the value to setval and then you increment it by increment. Okay. So yeah, what we are doing here is that we say that the answer is the previous answer, which is the value stored in the node. And then we check if the value setval is equal to -1 or not. If setval equal to -1, then that means we don't need to assign it to anything, right? So we can just add it by increment. Okay, cool. So in this case, what happens is that if in the update, the value of setval is, so yeah, let's come here. So if the value of setval is equal to -1, which means that we don't need to assign it anything, we just need to increment it. Then as we had done previously, we'll just say that answer equal to cur plus tr minus tl plus 1 into the increment value. Okay. But now let's come to the more interesting case in which the setval value is not equal to -1. Then that means that we first need to set this value and then we need to increment it. Okay. So what we'll do is we'll just first set this value to update.setval and then we'll increment it by update.increment and then we'll just multiply it by tr minus tl plus 1 since the node represents the indices from tl to tr. Okay. Cool. So yeah, I hope this is clear. So this is how we can apply this update to a particular node of a segment tree. And now let's come to the second function where we need to make changes, which is the combine update function. So now we have two updates. One is the old update and one is the new update. So again, we make two cases. So the first case is when the set val is equal to -1. Okay, so if set val is equal to -1, essentially what we are doing is that we have an old update. Okay, so in this old update, we have a particular set val value and we are not even changing that. We are only changing the increment value and we are increasing that increment value by new update dot increment. Okay, so if this doesn't make a lot of sense to you, just try to visualize what is happening. I'm pretty sure that it's quite easy and you'll be able to understand what's happening here. And the second thing is that the set val is not equal to -1. So in this new update, if the set val is not equal to -1, then the old update essentially becomes useless. So we'll just say that the answer is equal to the new update. Okay, cool. So we have made all the required changes in the three locations. And now we can just use this segment tree. We can just forget about all this jargon of code which is written here because you can be sure that it's going to do its work. So yeah, that's what we do. So we create a structure and then we just initialize an identity update, which is -1 and 0, because for assignment, we have already seen that the identity update is -1, and for addition, the identity update is 0. Okay, so we build in a segment tree. We pass in two values here. One is LL for the node, and we use the structure called update for the updates. Okay, so the size of the segment tree is going to be n plus 1, identity element is 0, and this is the identity update, right? Again, we build this segment tree on A, and then we answer the three types of queries. So if the query is of type 1, then, so what was the query of type 1? So in query of type 1, we need to increment it by X. So the update essentially becomes something like this. So you don't need to set it to anything, but you increment it by X. So the update becomes -1 comma X. In the second type of query, you need to set it and you need to increment it by 0. So the update becomes X comma 0. And in the third type of query, you just simply call the query function of the segment tree and pass the arguments L to R, and it's going to do its magic, right? So yeah, this is how you can use segment trees with lazy propagation, and you can use this in any contest, and you can solve any segment tree problem in a blazingly fast manner. It's also possible to do some very complicated type of updates using this particular template. For example, you can even add an arithmetic progression to a range, something like that. Okay, so things like that can be done with this template only by modifying the three locations that I mentioned, right? So yeah, I hope you got to learn something new from this video, and thank you for watching, and I'll see you in the next one.